Department of Information and Technology, IMT College of Engineering, Greater Noida. At IMT, we are committed to provide a value-driven culture along with creating a professional environment. IMT as a group, large and diversified, imparts knowledge in the field of engineering, management, education, law, pharmacy, etc. I take this opportunity to welcome you all in today's webinar on the current status, future prospects, and technological challenges of Internet of Things. A very warm welcome of today's speaker, Professor Shiva Prakash Sir, Director of Engineering, Dr. Gaurav Sinha Sir, HOD IT, Dr. Mahend Sharma Sir, and all spectators. It is indeed my great pleasure to welcome the speaker, Professor Shiva Prakash. He is currently working as a professor in Madan Mohan Malviya University of Technology, Gorakhpur. His total academic experience is more than 22 years. He has completed his PhD in Computer Science and Engineering from Uttarakhand Technical University, Dehradun, and Master of Technology in Computer Science and Engineering from MNIT, Allahabad. He has published 42 research papers in referred journals, 41 in international conference proceedings, 24 in national conference proceedings, and 10 in book chapters. His research interest is wireless networks, Internet of Things, cloud computing, fog computing, mobile computing, and design and analysis of algorithms. He is an active member of various professional bodies like IST, IEEE, and CSI. He worked as a session chair and program committee member for many national and international conferences. He is also an editorial member of many journals and reviewer of many international journals and conferences. He is a strong educational professional with a demonstrated history of working in the education management industries. Now I request Director of Engineering, Dr. Gaurav Sinha Sir, to please address the audience. Sir.
Thank you, Rupali ma'am. First of all, on behalf of whole IMT family, I take this opportunity to welcome our guest speaker for this live session, Dr. Shiv Prakash, who is Professor of Computer Science Engineering in Madan Mohan Malviya University of Technology, Gorakhpur. As we all know that Professor Saab is an expert of Computer Science Engineering, and the topic for today's live session is the importance and the future prospects for Internet of Things. We have been getting requests from many students because they were requesting about the future of Internet of Things. So we thought of organizing a live session with some expert who could answer the queries raised by the different students. And as we all know that in the coming future, we would be more dependent on information technology, Internet of Things, artificial intelligence. We have learned so many things from this pandemic, and we have learned that we have to incorporate these technologies in our day-to-day life. These are some emerging technologies, and there will be a vast, job opportunities in the coming future based on these technologies. As far as our, the students who go for the engineering courses is concerned, they learn basics in their engineering courses. But there lies a gap between the course they study and the skills required by the industry. So in order to fulfill that gap, we would request our expert today to answer the queries like what is the importance in the coming future of IoT, what are the prospects, future prospects, what are the risks associated with Internet of Things, and how it is going to affect life of each and every individual in the coming times. So I would give the stage to without wasting any time, I would give the stage to our guest speaker, Dr. Shiv Prakash. Once again, welcome to our guest, Dr. Shiv Prakash, and welcome to all the viewers who are watching this live session on YouTube and other medium. So thank you, Dr. Saab, for having accepted our request and taking time out of your busy schedule. Thank you and welcome. Over to Rupali ma'am.
Thank you, sir. Thank you so much. Now I would like to invite and welcome our eminent speaker, Professor Shiva Prakash sir, to address students as well as faculty members. Sir, please.
Thank you, madam. It's my great pleasure for giving this opportunity to interact with all the audience, you, and especially thanks to Director Professor Gaurav Sinha sir, Dr. Mahendra Prasad, HOD, and Madam Rupali Gupta, Madam Aruna, Madam. Especially thanks to Director Gaurav Sinha sir to give an opportunity to interact with the student and faculty members.
Sir, now you start your PPT. Sir, it's visible.
Thank you, ma'am. Today, I'm discussing, first of all, the basic things of Internet of Things, their working, need, applications, current status, future of IoT, technological challenges, and their research issues. As we know, it is evaluation or revaluation of $1 million questions. At early parties, I'll see this example, evaluation, and then after evaluation, the more you see this vehicle. So the evaluation are gradual process in which something changes progressively from one stage to another. Whereas revolution, a total turn around, a sudden or complete or fundamentally, or you can say radical changes in something. So the typically revolution leads to further evaluation. For example, innovation of the automobile was revolutionary. However, innovations such as ground mail, commercial transactions evolved automobile invention into a commercial enterprise. Internet revolution. Internet revolution as in the internet benefits both this 1969, 1999, and internet Greek 1995 to 2000, internet message this 2000 to 2007, mobile internet That's 2007 to 2011, and Internet of Things 2012 and beyond. This the Internet revolution, and now the 5 early technology evolution roadmap for Internet of Things. As this the in first year technology reaches this first year demand for expedite logistics and the first year, and second the 2 year this technology cost reduction drive web application etc, and third the ww connectivity and low cost geo location technology, the surveillance, security, transportation, documentation, management, etc. And fourth is the locating people and object training, etc. That is a low cost sensor leads to low cost sensors. And at the fifth year, the tele preparation of the telepresence ability to monitor and control distinct object. So, this is the as not technology advances, so will variety of upcoming applications. Next is the progresses index, growth in the Internet of Things, as the seen. This is the billions by 2020. I see with 1996, and then 2000 after 2004 as 5 billions, 0.5 billions, 2006, then 2012. This gradually there increases. These are the requirement or use of Internet of Things. So the sky is not a limit, it's only beginning with IoT. Another scenario, the impact of Internet. That's the impact of Internet education, business, communication, entertainment, medical health, and all the fields of existing fields. Next, Internet uses and population statistics. Internet uses and population statistics. This 2003 that you see the world population is 6.3 billion and connected devices 500 billions. In 2010, world population is 6.8 billions and 12.5 billions of connected devices. In 2015, world population has 7.2 billions and connected devices is 25 billions. And 2020, this world population is 7.6 billion and connected devices is 50 billions. Next, connected world. Connected world as another scenario. Game player at 5%, media players again approx 5%, and connected TV 8%, and phones 31%, smartphone 10%, tablet 5%, and desktop notebook 29%, other 3%, and e-readers approx 4%. So this is another scenario. Now, the typical view of Internet of Things as a industrial automation, smart health, smart home, smart city. So Internet of Things are the term Internet of Things was first used by Kelvin Ashton in 1999, referred to uniquely identifiable object and their virtue representation in a internet-like structure. So there's a lot of definitions uh, of the Internet of Things. The Internet of Things, also called the Internet of Object, refer to wireless network between objects. Usually, the network will be wireless and self-configuring, such as household appliances. That is this definition by the Wikipedia. And another Internet of Things refers to concept that Internet is no longer just a global network of the people to communicate with one another using computers, but it is also a platform for devices to communicate electronically with the world around them. That's by the Center of Data and Innovations. Center of Data and Innovation. And another this definition of this is Internet of Things. This term Internet of Things come to describe number of technologies and research disciplines that enable the Internet of to reach out into real world of physical objects, as this at in 2008. Whereas 2020, things having identities and virtue, personalities, operating in smart spaces using intelligent interfaces to connect, communicate within social, environmental, and user context. This and Internet of Things for marketing perspective, this enable communication between devices to exchange useful information that create new value for human need. Whereas technological perspective, things with identities and virtual personalities operating in smart spaces using intelligent interfaces to connect, communicate within social, environmental, and user context. Now, enabling technologies, RFID, sensors, smart technology, nanotechnology. So in RFID, that's to identify and track the data of things, where sensor to collect, process the data, detect the changes and physical status of the things. A smart technology that enhance the power of network by devolving processing capabilities to the different part of network. Nanotechnology to make a smaller and smaller things have ability to connect and interact. In state of art of IoT research group, the different research we categorize in three groups: MIT, Auto ID Lab, EPS Global. This is MIT, EPS, and EPS group. And second, EPFL, ETH, Zenith Information Communication System Research Group, and other. That's this University of Technology VRS group. Third, this Nokia, SAP, IBM, Google, Ambient, Metro Group, Siemens, Sun, Cisco, G. These are the different research groups or organizations are developing or enhancing the Internet of Things. And mainly you can say as a basic and normal way, we can say the Internet of Things is a network of smart devices that connect and communicate via some communication technology. That's or you can say via Internet. So this another the Internet of Things from as added as one more dimension as Internet is any time connection, any place connection, and whereas IoT this is facilitated that any things can be connected. That's object, devices, human being means everything possible to connect. Will affect your life. The question, Internet of Things will affect your life. These things is starting to talk to each other, develop their own intelligence. Imagine the scenario where your meeting was pushed back 45 minutes. This is communicated to your alarm clock, which allow you 5 extra minutes to sleep. So all the activity, all the things organized and need not to worry. That's automatically you can switch over to all these things, all the activities. So in such a way, the life is easier and time saving and can be more productive and enhance the even you can say quality of life also. So these are things that can easily manage and synchronized by IoT. Now, how IoT works? As the smart devices collect and exchange information, who as in the fashion that a machine to machine and with us. So as a internet and machine to machine are the machine to machine, just like the communication that like in the point to point. Whereas whereas remote whereas IoT this is a interaction between this machine to machine as well as pupils as means with us. This communication, this device to device, the communicating with all the objects possible and with human being. Remote control and monitoring. So the many other this how this work, remote control and monitor. We can control the devices from the remote places and as and you even you can monitor, operate automatically through the software, cameras and sensor. And these are the process possibly to automate and then doing the task without human intervention. So and the physical status of the things. Smart to enhance the power of network by developing processing capabilities to different part of the network. Nanotech make the smaller and smaller things have the ability to connect and interact. So this is the working of IoT and the structure of IoT. Structure of IoT, this view, the consisting of network devices, computers connected through the series of intermediate technologies where numerous technologies like RFIDs, wireless connection, and that's enable to connect and connectivity. So the first is tagging things via this RFID, and another the structure part, this feeling thing. That's a sensing acts the primary devices to collect the data from the environment. 1 minute. Feeling the sensor, shrinking via this nanotechnologies, ability smaller things to interact, connect. That's these is via these smart devices and thinking things, embedded intelligence. By the AI. Why Internet of Things need benefit of the IoT? So the need of IoT, the difference between with and without IoT. So Internet without IoT, the run to machine, telling them what to do feel. Whereas with IoT, the devices can interact, collaborate, learn with each other, share experiences. The ultimate aim of devices to reduce human interaction in the machine cycle. The machines here continuing to touch with each other and could be pre-instructed on what to do, when to do. This the need, another there's a dynamic control of industry and daily life, improve resource utilization ratio, integrating human society physical system, flexible configuration, universal transport, internet apps, technology integrator, efficient resource utilization, minimizing human effort, save time, development of AI through IoT, improve security. There's a need of IoT. Now, features of IoT. Features of IoT, as you can say, features of IoT. Features of IoT are this is first connect, then analyze, then integrate. Connect, analyze, and integrate. Connect, analyze, and integrate. Connect means to connect various things to IoT platform, that's device virtualization. This standardized integration of devices with the IoT enterprises. High-speed messaging enable reliable, secure, bidirectional communication between devices and cloud. Endpoint management, that's the manage devices, endpoint, identity, metadata, and lifecycle start for all the devices. Analysis, the collect and use it to build business intelligence. In this, the stream processing, that analysis of incoming data stream with event aggregation, filtering, correlation, processing, and so forth. And data enrichment, the raw data stream with the contextual information and generate composite stream. Even store this queries and visualize massive amounts of data with integrated cloud service support, enable big data analysis. And third, the integrate. After analysis, we need to be, the outcome of after analysis need to be integrate various models to improve use experiences. That's enterprise connectivity, means the dynamically dispatch critical IoT data, events, application, and processes flow. REST APIs means that based integration with the cloud application and IoT devices. And the command and control. Next integration part is command and control, means send messages to devices from enterprises, mobile app, interdependent to device connectivity. And this Raspberry Pi OS installation, and most important operating system supported by Raspberry Pi. Next, the architecture. So this Unity standard consequence of the Internet of Things architecture, which universally defined that functional area and their solutions. However, IoT architecture technology mainly consists of four major components: the sensor devices, gateway network, cloud management services, and applications. So this the architecture, as a well known, they have not fixed. This architecture is very at different for by different type of applications, but that's well known. And this four stage solutions IoT architecture. The stage first, this indicate stage first, the sensor and actuator, that the devices that are able to emit, accept, and process data over the internet. Sensor and actuator may be connected either through wired or wireless, or contains GPS, RFID, and most sensors need to connectivity through sensors gateway. The connection of the sensors actuator can be through our local area network or personal area in many ways. And second stage, the gateway and data acquisitions. The large number of data are produced by sensors, and actuators need the high-speed gateways and network to transfer data. This network can be the type of local area network, Wi-Fi, Ethernet, wide area network, that is WAN, GSM, 5G, GPRS, etc. Is IoT stage third. This analytics pre-processing. This architecture, hardware and software gateways analyze, pre-process the data before transferring it to the cloud. Data read from the sensor and gateways are not changed from the previous reading value. It does not transfer over the cloud. This saves the data used. And third stage, data, four stage, the data center and cloud. Data center and cloud. The data center or cloud come under the management services, which process information through analytics, management of devices, and security control. Besides this security control and devices management, the cloud transfer of the data to the end users applications such as retail, healthcare, emergency, environmental, energy, etc. So now this IoT technologies. IoT technology is a different type of technology used in communications. And next is the post escapes the tracking of the Internet of Things. Tracking of Internet of Things uh, is this you can see this source the is a growing Internet of Things, and this different type of technologies, that's RFID, NT, NFC, 6-low-pan, Zigbee, ZW, UWB, Bluetooth, and then Wi-Fi, and license-free spectrum, that's 7, and 2G, GSM, ACE, CDMA, 3G, GPS, GPRS, cellular 4G, LTE, LTE advanced, etc. As these technology is used in this the growth of the Internet of the Things. So now Internet of Technology as and protocols. Thus, the 7 most important communication protocols that you see are the Bluetooth, Zigbee, Wi-Fi, Z-Wave, cellular, NFC, and low broadband. So several communication protocol and technology used Internet of Things. Some of the major technology protocol, this IoT communication protocol, are the Bluetooth, Wi-Fi, and its etc. Now, the few applications as this as a wearable tech, smartwatch, wearable gadget such as Fitbit band and Apple watches synchronize easily with the mobile devices. With the mobile devices, this help it capturing necessary information such as health, heart rate monitoring, sleeping activities. These also help in displaying data notification from the mobile devices on to them. And next device, the application is this smart city. The scenario as shown, this is smart city. This world first smart city to be completed in by the 19 and then in 2015. San Diego, this Oregon control grid, the world's first smart city being built in Asia, and its promise to serve as the experiment for the high-tech and the collapse this present era of the human industrial civilization. And next application that driverless car. This by this Internet of Things and AI, or I can say IIoT with the this with the possible this driverless cars that can be travel or for transmission. They successfully they tested at Venus around the world, including Austin, Texas. The recently Singapore Nanyang Technological University by the Nanyang Technological University will be vehicles very first real world environment for from watchful eyes of its creator. This knowing that the pick that can be picked up passengers all by itself, and seem just that little bit closer, and doing without the driver and conductor. This pick up the passenger as well, drop their destination, etc. Done by automatically by this driverless car. Next is example is smart city. As we know, this smart city, and another example, this IoT data analytics. IoT data analytics. This business are increasingly using IoT data analytics to determine trends, patterns by analyzing big and small data. So the IoT data analytics applications can analyze structured, unstructured, semi-structured data, extract meaningful insights. So this IoT apply data analytics, investigate different type of data, including motion data set, geographical data, health care data, and I can say the business perspective, descriptive analysis to improve customers' knowledge, enhance operational efficiency, and create business value. Another application that is smart grid. Smart grid. So this smart grid, this industrial application of IoT, the grid allow real-time monitoring data regarding supply and demand electricity. Next application is smart farming. Smart farming, the application optimizing a lot of different activities, such as determining best time to harvest plant, creating fertilizer profiles based on the chemistry of soil, and sensing soil nutrient moisture level. According to that, farmers are uh, doing their agriculture. Uh, so this example, the farming IoT example farming, this include a smart element, and these devices can detect weather condition, other environmental data, and smart farming can revolutionize agriculture industry. So now this supply chain management and smart barcode, as everyone knows, the use of barcode, and these barcodes, the inventory management, retailers, readers support AI-based digital signal processing. And next, this is the connected healthcare system. Connected healthcare system. This system, this numerous application in the healthcare industry. The technology can be used to provide high quality medical services using smart medical devices. IoT medical devices can help real-time monitoring patient remotely, etc. Now, you can say everybody known about the lot of applications, as we simply named these application, and you see the scenarios of that application. Connected factory, those there's the productivity and the process automated with the help of IoT. This another application of IoT, the smart home. Smart home, and next is smart weather station. Smart weather station and smart washing machine, smart lighting, smart AC, smart sleep system, an application scenario that's transportation. This are used in the transportation, and application scenario that's a tracking monitoring system. Tracking monitoring system, this IoT help to track this vehicles and persons and know their location, etc. So very helpful these applications uh, with the help of enhancing the usability and quality of these application automation process. Now, manufacturing revolution from industry 1 to industry 4. This industry 1 to industry 4, the industry first, industrial revolution, the key changes, introduction to mechanical production equipment driven by the water stream, and industry 2, that's the key changes, introduction of mass manufacturing production line powered by the electric energy. Industry 4, the third, the industrial revolution, the introduction to electronics, PLC devices, robots, IT, and main uh, changes as that industry 4. The industry 4, the key changes, the introduction to IoT, cyber physical system driven augmented reality of real-time intelligence. So, this IoT 4, as this IoT is at the stage core of the fourth generation revolution. Now, this another this you can say while this in this view of Internet of greenfield innovation enabling IoT. This simply the scenario you can see that is a greenfield innovation enabling IoT. So this greenfield and innovations enabling IoT, that as you can say manufacturers beginning to implement IoT solutions and relieve IoT requirement for future growth. 35% are currently collected and using data generated by smart sensor in enhance manufacturing operation process. 75% believe it extremely moderately important that US manufacturers adopt an IoT strategy in their operation. 38% currently enable sensors in products that enable end users, customers to collect sensor generated data. The North America market, the IIoT will reach with dollar 599 billion and with a CAGR of 13.1% by 2001. So this is the greenfield innovation enabling IoT. Next is current status and future prospects of IoT. So as this already discussed, this how this is IoT current as well as in future prospects of IoT. So change now technological, the open issue challenges, and future research direction of IoT. So, this IoT can meant the use of the internet way the required by its end user. Feature also has the face some of the open issue that directly or indirectly associated with the concept of IoT. The most common of them have as availability. First, availability, the realization of IoT must be based on the existing hardware, software that provide anytime, anywhere access as well as services. Entire set of understood as the different unit. Hence, awareness association among hardware software by end user can contribute towards channelizing the vision of in a much more effective ways. The reliability, the basic aim having the enhanced reliability to increase the success rate of IoT service by virtue its capability delivering information, it becomes critical aspects. The shortcomings due to system failure, threats from intrusion always keep the reliability of framework is one of the major challenges in IoT. So the persons how to realize on the system in their failure. So next is mobility. Mobility is another challenge for the smooth implementation of IoT, as most of the applications are based on mobile interface, since connectivity also play a vital in the mobility of the data. Hence, failure in connectivity among non-stationary devices are often taken as incapability on the IoT for not being capable enough to transfer data from origin destination. So this is the mobility. Due to mobility, how to cope up this failure due to mobility. This is a main challenge. The working ability and performance. Working ability and performance. This capability and performance of IoT services are big challenge. So this performance is directly associated with the underlying technologies. It is very much mandatory to keep service updated and enhance time to time meet the requirement of the user or enhance the services provided to the user. So data confidentiality. Data confidentiality that remains one of the most critical aspects in terms of challenges becomes of the constant changes in the terminology and requirement in the users. It indeed how to find a stable ground of data confidentiality. And few more that is management of the network and its resources. Management of this network and its resources, mainly establishing connection with the trillions of devices that serves provide are often face issues of managing as well as addressing the issue. How to manage and how to address them uniquely identify so that you can identify the fault configuration, constantly managing performance, security of the devices and its channels. Scalability, another is the scalability. It refers to the concept of the adding newer devices over the existing paradigm without affecting existing services. And interoperability to handle many heterogeneous devices, it is indeed a difficult task. However, SUs also faced at the time of establishing synchronization among different platform. Hence, interoperability often remain an issue of connecting IoT. Next, software-defined network. Software-defined network play a major role for enhancing the services of the IoT. As we know that software-defined network is one of the software layer, just like firmware, in between to uh, application and the users. So all the operations that are managed centralized as a in general scenario, that is you can say this control and data flow are separate, and whereas in this software defined network, with this software defined network, uh, separation the control and data plane. So the control are centralized, so you can manage easily control the devices and manage all the things with the help of software defined network. Visualization. Visualization is another issue. I can say some challenge. There are the lot of concern related to creation of virtual version to eliminate ongoing concern of the modern day applications. So it's a development, proper deployment, adaptability, existing scenarios are one of the biggest challenges faced by the IoT. And next is the standardization process. Standardization process, the many day-to-day, many devices are connected to becomes the part of IoT. So how to standardize the process and the devices developed by industry. So need to be an standardization process. Standardization process are incorporated so that they can support numerous range of application, even with the use of semantics, ontologies, machine readable codification that occurs at the time, which initially results in different uh, scenarios encountered from time to time. And last, capabilities with the fifth generation communication. So this as IoT that is capable, high speed communication system is facing a rapid transformation. Major innovation always are required. So the sum of the commonly faced issue by 5G communication techniques for IoT based implementation. Most common faced issues is enabling physical layer techniques of the modulation, timely handling of the multiple input, multiple output, error control, coding, and lot of effort have been carried out in the name of IoT. There is still several aspects of which IoT need to nurture. Now, this SU, and as we know that SU that big comes the challenges when we taking as a challenge. So the major challenges that is based research and industry. Majority of challenges have been identified that these research and industry. So most IoT technology themselves allow identification, the development challenges after outlined roadmap activity, attain reliable, well practical solutions. So this identification technology identification technology is a major challenge to identify the devices, to map, provide the uniquely identify these devices. The billion of devices are gradually increased, so the major challenge to identification of these devices. Internet of Things architecture and technology. The biggest challenge this Internet of Things architecture and technology that is imperative for the provides uh, requisitor to communicate meaningful with each other, irrespective of being heterogeneous nature. So establishment of communication technology. Establishment of communication technology. The biggest challenge faced the establishment well-oriented communication, that is proper deployment, constraint-free mobility of the item, cost heterogeneities, uh, communication ability, network. This another is the network technology as implementation of the vision to the reach out the object of the physical world to bring them out of internet net, network discovery, that overcoming existing network dynamically to change continuous evolving of the things so that they can feature varying degree of autonomy. And this network discovery after this correct identification of data and further signaling process. Correct identification and further signaling. The semantics that interoperability means required to enhance the interoperability, correct service discovery, and for that required service composition as well as data sharing and collaboration, and also correct identification of autonomous agent. Standardization is required to standardize the devices and other this technology. This standardization that are required the security related issue, proper management of ongoing services, correct identification of services, interoperability, and data confidentiality, data encryption, and this also the proper management ongoing the services. So now next is the challenges faced by various applications. These challenges we can see with application to application, that smart mobility. So smart mobility as awareness regarding the concept, a lot of in when hello 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 जी ma'am. Hello. Within 5 minutes. So these challenges faced by various applications. First, as you can say, smart mobility. What are the challenges? And when in developing the application of smart mobility. So this unawareness regarding the concept and lot of investment requirement in bringing up the infrastructure, existing structure, not equipped, capability issues, and high cost involved in the installation. And whereas the grid, smart grid, in the smart grid, the protocols vary according to location. These protocols are varies according to location, and this on the memory space, self computational is the time consuming. So, in the no proper data acquisition framework available, so the problem occurs due to variant in tariff. In the major challenges in developing smart grid and smart house building. So when we developing application of smart house building, the requirement differ from environment to environment. The higher cost involved in installation of devices, knowledge requirement to reconfigure if disconnectivity occurs. How to reconfigure if disconnectivity occurs? Variations in the protocol. Public safety and environmental monitoring. Public safety and environmental monitoring, the requirement differ as geographical location where steers devices with the process of the time sensor installation is open. High cost involved in selection of devices, difficult to manage enormous data, and variations in the protocol, lack of in terms of memory, space, knowledge, etc. And medical and health care. The application of medical and health care, and inadequate knowledge to user sensors are the highly overpicked, high complex mechanism requires time to time update according to patient health timely update requirement. Industry processing mainly this type developing this type of sensor get outdated from time to time, then change the malfunctioning and this updating this sensor and replacing these sensors. Agriculture and breeding, the sensor replacement at physical location, lack of awareness among farmers. These are the major challenges in when developing agriculture-based application. Independent living issue difficult to resolve in case of malfunctioning. No number of sensor increase as per requirement. Risk and privacy. Risk and privacy. Risk and privacy. Business implies client information could be destroyed, altered, stolen, exposed, held as the and the understand IoT device data collection policies, what information is gathered and how long the data kept, what is your data used for the different the marketing, research, etc. That is a risk of privacy and the security is the major challenge. So this risk of information security, that direct cyber incident, indirect cyber incident, direct cyber incident, remote control monitoring, head office, supply chain, customers, whereas indirect cyber incident, downstream effect on the IoT security infrastructure, malware attacks on the IoT devices, etc. not directly come at a future research direction. Future research directions, this future research direction, the concept of IoT has come a long way over the years, keeping given ever interaction spectrum of IoT, some failure related to queries have been presented. So we find ourselves enclosed in new horizon. This what? Hello, hello, ji. This what would be the next big step to correctly identify, handle huge trends that are being added over the internet. Another is how will the next generation information system works in synchronization with especially when technology is not constant, and how will the newer concept overcome in inherent complexity, data volumes, providing the useful data uh, support system. Which IoT business model will drive the next generation global business, and will the object only rely upon only internet services for communication in the future? Business, a research company, IoT Service Global Market Report 2021, COVID-19 Impact and Recovery to 2030. This is you can say, the global IoT service market is expected to grow in $139.24 billion in 2020 to $162.39 billion in 2021 at the compound annual growth rate CAGR of the 16.6%. The Internet of Things services market is expected to reach $381.16 billion in 2025 at CAGR of 24%. The report covers the IoT services market segment by the type: professional services, managed service, and manufacturing, retail, IT, telecom, transportation, smart building, smart manufacturing, smart transportation, logistic, smart healthcare, smart retail, smart energy. And conclusion, despite the rich and fast-growing field of IoT, it has been broadly described the key and current standing uh, and future prospect of IoT. It evolves from time to time along with the various communication technology, various object, interface, and communication purposes. Highlight various application area of IoT as I, IoT, this by the Internet of Things. Today's the IoT have different variant, industrial IoT, uh, as well as IoE, Internet of Everything. So today's Internet is Internet of Everything. So, thank you. These are references I have prepared, taken the pictures from these references. Thank you.
Thank you, Dr. Saab. Thank you so much, Dr. Shiva Prakash, for giving us such valuable information to all the viewers. And we really we are grateful to you for taking our time out of your busy schedule. And once again, I would like to thank you, and we would like to hear more lectures from you in coming future. And thank you. Over to Aruna ma'am.
Thank you, sir. On behalf of IT Department, IMT College of Engineering, Greater Noida, I take this opportunity to propose vote of thanks. I take immense pleasure in extending my sincere thanks to guest of honor, Professor Shiva Prakash, who highlighted towards current status, future prospectus, and technological challenges of Internet of Things. I extend my heartfelt thanks to one and all for their unflinching support and coordination. With these warm words and a kind message, we move to the end of the today's session. Current status, future prospectus, and technological challenges of Internet of Things by Professor Shiva Prakash, sir. Thank you, everyone. Thank you, sir.
Thank you to given this opportunity, and I am happy to communicate and interact with you people, and I am always ready to help and interact with you all.
Okay. Thank you,
Thank
sir.
you, sir, for giving such opportunity to interact with to all the faculty members of IIMT, and thank you very much.
Thank you.